Okay, welcome to this functional group under ring chemistry tutorial sheet 1 solutions question 1. So question 1 was about nomenclature of aldehydes and ketones. Aldehydes, they have a functional group of this structure. These are aldehydes, and naming them, the suffix will always end with this. And then a ketone has a structure looking like this. Then the suffix will always end with this. Then the parent name will just depend on the number of carbons. The one carbon with methyl, 2 ethyl, 3 prop, like that. Okay, so now let's dive into the tutorial sheet so to answer these questions. Question 1, question 1a, it had a structure looking like this: CH2, CH3, then a methyl here. So for us to name this one, let's first count the longest chain of carbons. So we find that it is 1, then we have a 2 there, a 3 there, carbon number 4, and carbon number 5. So we have 5 carbon. So we're going to draw 1, 2, 3, 4, 5. Then we can see that on carbon number 2 we have a methyl, so we'll draw a methyl. Then on carbon number 3 we have a carbonyl group, so we'll draw it here. Yes, so from this structure we can see that we have a functional group of a ketone. A ketone is there, and how many carbons are in this ketone? There are 5. So if there are 5, the name will be a pent. Since this is a ketone, it will end with a pentanone. Where exactly is the ketone? It's on carbon number 1, 2, 3, 4, 5. So the ketone is on number 3. So put a 3 there to show that this is 3-pentanone. Then we also have other substituent which is on carbon number 2, a methyl. So it will be a 2-methyl 3-pentanone. So this is the name of this structure. Okay, then we move on to the next compound, which is B. So B was looking like this. This was B. CH2, CH2, CHO. So if this is kind of not making sense, or not able to see which one is a functional group, you can draw it into this form: 1, 2, 3. On carbon number 3 you have this functional group like this. So from here we can see the functional group, which is an aldehyde. We have an H at the end. This is an aldehyde. So now we can name it, or we can number it: 1, starting from the functional group: 1, 2, 3. Then this which is attached to carbon number 3 is what is called a phenol. A phenol because it's dialects attached to the functional group chain. Okay, so let's start naming with this substituent. The phenol becomes a substituent. So we'll say it's a 3-phenol. So it's a 3-phenol. Then what's the parent name? If it's having 3 carbons, it's called a prop. Now it's an aldehyde. We said aldehydes end with this, propanol. So it's a 3-phenyl propanol. That's the structure. Then we move on to structure C, or compound C. So compound C was written as CH3, C double bond, CH2, 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 C double bond, CH2, CH3. Still, if you can't see the functional group, draw it in a line method. So, provided you count the number of carbons. So here we have 1, 2, 3, 4, 5, 6, 7, 8. So you draw a line bond of 8 carbons. 2, 3, 4, 5, 6, 7, 8. Then on carbon number 2, you have a carbonyl group, and on carbon number 6, another carbonyl group, like that. So from here you can clearly see the functional group which are present, which are all ketones. So if you have two ketones, it is called a dione, right? Then the number of carbons which are present are 8, so it's an octane for 8. So where exactly is the dione? It's on carbon number 2. This is carbon number 2, and on carbon number 6. That's where we have the ketone. So it's the name of the compound will be 2,6 octadione. That's the name. Then we move on to structure D, or compound D. Compound D had a structure like this one. It had a methyl group here, methyl group there, and I'm sure now you can able to tell which one is a ketone, which one is an aldehyde. So from this we are able to see that it has a functional group of an aldehyde. So this is an aldehyde, and it has a substituent. So we start counting from this where it is attached as carbon number 1, and this one as carbon number 2. So on carbon number 2 we have a methyl, so it is a 2-methyl. 2-methyl what? Then you name the rest of the structure which is remaining, and the rest of the structure is a cyclo. It's cyclo. A cyclo what? It's a 6-linked structure, so it's going to be called an hexene. Cyclohexene. Now we have an aldehyde functional group. That's where this name comes in as a carbaldehyde. So this is the name, 2-methyl cyclohexene carbaldehyde. That was the structure D. Then structure E. Structure E, you have CH3CH with a double bond, CH2, C and hydrogen. Still, if you can't see the functional group, number the carbon and draw it in a line method. Start counting from where you feel like there is a functional group. So start counting from here: 1, 2, 3, 4, 5, 6. We have 6 carbons, so draw a 6 carbon in a line form: 3, 4, 5, 6. And on carbon number 1 we have a functional group of this, right? Then on carbon number, count it: 1, 2, 3, 4, 5, 6. There are 6. So we have a double bond between carbon number 4 and carbon number 5. Between carbon number 4 and 5 here, this is where we have a double bond. So from this structure we are able to see that we have an aldehyde and an alkene. Okay, so this has two methods of naming it. You can name it starting with where the double bond is, which is on carbon number 4. So 4, and this is an aldehyde, so you're going to name it as hex. Since you have 6, it hex. Instead of A here, we put E because of a double bond. Hexino. 4-hexino. This is fine. Or you can elaborate more by saying this will be a 6, so have hex. Then you tell us where the double bond is, which is 4. Then you also indicate where the aldehyde is, like this. This is also fine. Hexa 4 in 1 ion. This is 4E. Then we also have the last compound, which is F. The structure was this. Was the structure. You have a methyl there, another methyl there. Okay, so how are we going to name this one? We are able to see the function group is a ketone. Then it has substituent of methyls. So you start counting going anti-clockwise, because it's going to give us the lowest number of substituents, which is 1, 2, 3, 4, 5, 6. So you name the substituent first, which is on carbon number 2 and carbon number 5. So it's 2, 5. What? Dimethyl. There are 2. Dimethyl. Okay, then what is the rest of the structure? It's a ring, so it's a cyclo. A ring of 6 is called a cyclohex. So this is a ketone, so it will be hexanon. Then you are done with part A. So now let's move on to part 2 of question 1. Part 2 of question 1. This one involved us to drawing. We are given the name, now we are going to draw. So first question, we'll draw. They said you draw 3 methyl butanol. So from this, you need to find first the parent name is but. So but has 4 carbons, so you draw 4. 2, 3, 4. Okay, this is an aldehyde because of the suffix. So we're going to find that the aldehyde will be at the end here. Then this will be carbon number 1, 2, 3, 4, as it is but. Then on carbon number 3 we put a what? A methyl. Then this is a 3-methyl butanol. Then okay, so add. Right. Okay, then B. Move on to B. They said you name 4-chloro 2-pentanone. Okay, so as usual you start with the parent name. Pent has 5. You draw a 5 carbon. 2, 3, 4, 5 carbon chain. Then this is a ketone, meaning the functional group is in the structure and exactly on carbon number 2. So if we are to start numbering from here, 1, 2, 3, 4, 5. So the ketone is on carbon number 2. We put the functional group of the ketone there. Then on carbon number 4, 4-chloro, we put a chloro there, a chlorine. So this is a 4-chloro 2-pentanone. Right. Then C. The C is not looking nice. Okay, C. So C was saying you draw a phenyl aldehyde. Okay, so to name this one, okay, you have an acetaldehyde. Acetal means 3, it's ethyl. So this can also be called a phenylethylaldehyde. Okay, so we have a 3. Let's draw a 3, 2, 3. It's an aldehyde. So aldehyde will be at the end there. We have 1, 2, 3. Then on this we have a phenyl. So a phenyl is on the carbon number 3. It's directly attached there under the conjugated double bond. So this is a phenyl acetaldehyde. Okay, then we'll go to D. Oh, the D note looking nice. Okay, the D was saying cis 3 dates butyl cyclohexane carboaldehyde. Okay, yeah, a very long name. So we have a carboaldehyde, meaning it's outside the ring. So we start drawing first the ring, which is a cyclohexane. So we draw a cyclohexane. Okay, cyclohexane carboaldehyde. So somewhere there we have a carboaldehyde. It's an aldehyde. We add an aldehyde. Then saying we have a date butyl. Where is a date butyl? It's on carbon number 3. So we start numbering from the point you attach the carboaldehyde, which is 1, 2, 3. So on 3 you have a date butyl. A date butyl is a structure which looks like this. So hence you have drawn your cis. Now to show that this is on the cis, if all these are going to be on the uh, on the on the wedge, then also this one is also going to be on the wedge, so they're on the same side. Okay, yeah, same sides, different color. Okay, here same side. So this was it on this question. Can move on now to question to part. Okay, to part E. Part E. So part E was saying we name 3 methyl 3 butanol. So there is an E here. So the parent name is but, meaning it has 4. So we'll draw 4 carbon chain. 2, 3, 4. This is an aldehyde. So there is an aldehyde at the terminal end there. Then we can number it 1, 2, 3, 4. They are telling us we have a 3-butanol, so meaning E here to mean that there is an alkene between carbon number 2 and 3, between carbon 3 and 4, between carbon 3 and 4 there is a double bond. And on a 3-methyl, on the same carbon number 3, we have a methyl functional group, a substituent. So this is a 3-methyl 3-butanol. Okay, then go to the last part, which is F. Okay, F, we have to name 2 1 dash chloroethyl 5 methyl heptanol. Okay, so we start with the longest carbon chain, which is heptanol. Hept means we have 7, so draw the carbon chain of 7, 2, 3, 4, 5, 6, 7. Then we start asking us, is this a ketone or an aldehyde? So it's an aldehyde, so we have an aldehyde at the terminal there. 1, 2, 3, 4, 5, 6, 7. Then on carbon number 5 we have a methyl, we add a methyl. Then these in the brackets, they all mean that they are only carbon number 2. They are on carbon number 2, so we'll go on carbon number 2. Then we'll add a chloro and a methyl. How are we going to separate them? So an ethyl, we start counting. Ethyl has 2 carbons, so it's 1, another one there, 2. Then on this same branch we have 1 chloro, meaning on carbon number 1 on this branch there is a chlorine. So this is a 2. On carbon number 2 there is a 1 chloro and an ethyl. Then the rest 5 methyl heptanol. This is the structure. Thank you very much. This is a question 1.